Okay, this learning target says that you can factor special cases. If you recognize them, some of these factorings can go very quickly. One of the special cases is difference of squares. And if we look at these two, x squared is a perfect square because there's a number or a letter times itself that equals x squared. And 9 is a perfect square because there's a number times itself that equals 9. And then there's a minus in between, so this is called difference of squares. And we learned that if it's difference of squares, the way we could factor this is, well, we'd write it in factored form first. We think what times itself is 9, and it's 3 and 3, and we notice that there's no middle term. We talked about how we do the opposites there. To prove that you do opposites, we wrote it out like this and said, well, let's just look at our box here when we do that. And you'll notice how the two that we are going to put together right here, the signs are opposite, so they're going to cancel each other out. And that's why we're missing the middle term there. There's one other one also that's called the sum of squares, so that's the difference of squares. Sum of squares, you can probably kind of guess what that's going to look like. X squared, and let's say plus 10x plus 25. If you notice that your first and last term are perfect squares, and our indicator is right here that tells us both signs are going to be the same. We look over here, they're both going to be pluses. So we put in pluses for both. The square root of 25 is 5 and 5. And if you check that real quick, you can tell that that one is going to, when you put these together, since they're the same, that's how you get the 10x that's up here in the middle there. Okay, so if you recognize those special cases, the problems can be done pretty quickly.